Hi, welcome to the second tutorial showing how to use matplotlib to demonstrate the optimization process that we set up last time, where we used torch in order to fit a parabola basically with a simple multi-layer perceptron. We're going to start with the Jupyter notebook that we used last time. So it's right here. I'm going to make a duplicate of it so I don't overwrite my original copy. And then I'm going to rename it and just call this tutorial 2. Okay, so here's our notebook from last time. Just going to tell it to run all the cells. And then down here at the bottom, I'm going to say that we are starting here. Okay, so to pick up from last time, the first thing we want to do is I'm going to define a function which makes a MLP. So I'm going to say define a function, make MLP. I'm going to make the number of weights a variable, and also the number of layers. So this time we used 3, we can do the same thing this time. I'm going to come up here and just basically copy this code and just slightly modify it in order to make this function. So I don't need this in right here, we have that as a variable. So I need this first layer for sure. That goes from 1 input to n inputs. Then here, I'm going to say for j and I and range layers count -2. So -2 because we're going to have a first one that's special and a last one that's special. So everything kind of between. We just want to keep looping over this end to end. This is what could be repeated. Once I do all that, then I need to add a final layer which takes my n and goes back to 1. Finally, I need to return something. I'm going to return MLP. So we can try it out. MLP equals make MLP. There you go. You can see that it's working. You can also try, let's say 104. And you can see now we have the correct number of linear layers. So 1, 2, 3, 4, and the number of intermediate weights is 100. Last time we put together this function which would basically take a step in the correct direction. Just to make things easier, in just a minute we're going to do the same. We're going to also put this into a function. So I'm going to say define do step, and I want to make it pretty generic, so I'm going to say that it can use any MLP that we're going to send it. So I'm going to call it my MLP as an input parameter. Also the learning rate that we want to use, so we can change this in the future. We'll also give it a default value of 1e-1. So just like last time, I can basically just take and copy this code, paste it here, and just change a few little things. So it's the MLP, it's now going to be my MLP. I'm going to take in whatever the current xb value is when I create this function, like y prime. YB can be compared to y prime, take the loss. I don't need this anymore because it's defined in my function. Then for name param, and I'm going to change this from MLP to my MLP. I'm going to take a step in the correct direction, and finally I'm going to zero the gradient. Okay? So I can test to see if it's working. I can say for I in range, let's say 100. And then I'm just going to call this do step. Okay, that worked. Then I should be able to plot these two guys, but we've run into a problem. We don't know the y2 is here. So at the end of this do step, we can just return a value, return the y values. So we say y prime squeeze. In fact, we'll go ahead and do the squeeze that we did last time and also detach it. I'm going to call that the output. This is y prime out. And then I should be able to compare my x2 from before and see what we get. Apparently, there's something that's not quite right. Oh, this should be x. There you go. You can see that it's working. Just to show that if I regenerate my MLP, like make a new one, I'm just going to reset the weights, then I call this. Then I call this one time. See, it's bad prediction. If I say take 100 steps, it's a lot better. Okay, so that's working. Now we want to kind of put stuff together and make a animation. So first thing I do is import a few things. I'm going to say from matplotlib.animation import FuncAnimation, and also so we can view it in our Jupyter notebook and in our Jupyter we can say from IPython import display. And I probably spelled something wrong. IPython display. There we go. Okay, so if I go to the IPython documentation, or the matplotlib FuncAnimation, and we look at the documentation, you can see generally what we need in order to make this work is a few things. So one, I have to make a figure, which I'm going to have to pass in. Also, I'm going to have a function that's going to be called at each frame that should update my figure. I can tell the number of frames I want. Also importantly, in this function, it needs to have the signature. I can give it these fargs if I want to pass it additional things. So let's do that. And in order to do that, I'm going to say, I'm going to make a new figure. Then I'm going to add some stuff to it. Where I'm going to explicitly set my x limit. So I'm going to say go from 1, 1 to 1.1. And also we can set y limits on this axis. So 0.2, negative 0.2 to 1.5. Then I'm going to define the thing that I want to edit in the future. This is going to be an object called line. And right now we're going to plot and just say we have nothing here. This is going to be the prediction. Also, I want to add to this plot my existing true values, which is just this basically. Let's copy and paste that. Except for instead of just using generic PLT, I'm just going to say use that particular axis. And then we can also add the legend. And we have some air. Line object has the background light bowl. So I just misspelled label here. There you go. You can see there's no prediction right now, which is fine. Next, we're going to define this function that we want to pass to our animation. So I'm going to call this frame function. Frame number has to be an input, and also we were going to want to pass it the MLP that we want to update. So we're going to make that an extra parameter that we can add. So we say pass the MLP. Just to make sure that it's always working, I'm going to say if the frame number modulus 50, so every 50th frame, if that equals 0, then print. And use an F string here on frame, just so you can make sure that things are actually working. Then I'm going to come up here and basically do this exact same thing. I'm just going to copy that code. So I'm going to take this MLP, do a step on it, and get this y prime out. The only difference now is I want to take this line, and I'm just going to set its data. Set data, where I'm going to use the x and then y prime out. Next, I'm going to actually make my animation. So I'm going to call I'm going to make an object called animation or anim, and I'm going to use my FuncAnimation. I'm going to pass in the figure that we defined right here. It should still be an active object. And for the function that we want to call, say call this function. We also need to pass it some args. So by default, it's going to get this frame number, but we also want to pass it this MLP. If I look back here, I say I can call an initialization function. This fargs is the additional arguments to pass to each call of func. So you can also see it needs to be a tuple. So I'm going to make a tuple here, and we want to pass MLP to our function. Let's say we want to optimize for 300 epochs, so I want 300 frames. If I go back to the documentation here, this interval is the number of the delay between frames in milliseconds. So it's kind of just up to what we want, but I'm going to say 20 is probably reasonable. Finally, just the way I've set it up is with the boolean equals false. Okay. So that we have a fresh MLP each time, I'm going to make a new one. So I'm going to just copy this, put it right before here, and then I'm going to run this. You can see it didn't do anything. It's waiting for us to actually ask it to make the video. So I'm going to say video equals animation to HTML 5 underscore video. And now it's going to actually generate each of the frames. Okay, so it finished doing it. And we actually want to view our video. It's going to say HTML equals display HTML video. And then I'm going to use the IPython display to view the actual HTML. There we go. You can see our animation of our prediction getting better and better, and it's obviously going in a loop. But it shows you the general idea that first it's going to get the average correct, then slowly get the general the V shape, and then after that work out some of the nuances of that particular V shape. If I ran it for more frames, there would be more epochs, and it would improve even more. So thanks for watching. I hope that was helpful.